Evening everybody, dear student, welcome to Infinity Learn by Sri Chaitanya. Dear students, in the last class we discussed already types of functions. I have given the summary and important points related to types of functions, right. In this class, let us just recall the important points, as well we will focus on the problems, how to find the types of the functions within no time, right. Only 2 points are enough. Just if you have interest in kind of functions, it is very easy to observe a particular function is 1 1 or not, onto or not, right dear students. By the way, for the new student, this is BS Math faculty for IIT JEE, right. You see, in the last class we have seen types of functions, especially injective function. One second, right, injective function, which is also known as 1 1 function. Second one is surjective function, which is also known as onto function. Next one is bijective function, that is of course bijection we call. Injective function, let me recall just the important point. A function f from a to b is said to be injective function if distinct elements of the domain have distinct images. That was the first point that I have explained. Then point number 2, if a function is not 1 1, we call it as many one function, right. Then point number 3, if f from a to b is a 1 1 function and a b are finite sets, then n of a is less than or equal to n of b. Then point number 4, how to check whether a given function is 1 1 or not. If it is differentiable function, you just see its derivative f dash x. If f dash x is always greater than or equal to 0, or always greater than less than or equal to 0, always in the sense for all x belongs to the domain. Of course, equal to 0 should be there here and there. In such case, the function will be either strictly increasing or strictly decreasing, so the function will be 1 1, otherwise many one. And I have told you friends, when a particular function is given, like you see, if any horizontal line cuts the curve at more than one point, it is not a 1 1 function, because there will be 2 inputs at least for the same output. So, this is not 1 1 function. Then point number 6 is number of injective functions, that is, if n of a less than or equal to n of b and both are finite sets, number of injective functions is n of b p n of a. You know how to compute. For example, 8p3 means simply multiply 3 numbers back from 8, that is 8 into 7 into 6. Of course friends, npn will become n factorial. If you want number of many one functions, then total number of functions n of b power n of a minus number of 1 1 functions you can write friends. All these points we have discussed elaborately in the previous video, right friends. The next, surjective function, or what we call onto function. You see friends, a function f from a to b is said to be onto or surjective if the range of that function is same as codomain. That means, if every element of the codomain, you see, if you take every element of the codomain must have pre-image. In such a case, we call the function is onto. If it is not onto, we call it as into function. Then friends, if a b are finite sets and f is an onto function, n of a will generally be greater than or equal to n of b, right. Then next friends, how to check whether a function is onto or not? Simply observe the range and check with the codomain given. Find the range and check with the codomain given f from A to B. If it is given, B is codomain. If range is same as codomain, it is onto, otherwise into. So, while checking a function whether it is onto or not, finding the range is an important concept, right. Then friends, fifth one, number of onto functions, especially suppose A, B are finite sets, A has m elements, B has 2 elements, then the number of onto functions is total number of functions minus 2. 2 means when all the entries are mapped to the first element or all the entries are mapped to the second element. Suppose friends, if both have equal number of elements, in that case if the function is 1 1, it is onto, if it is onto, it is 1 1, in that case the answer is m factorial. Suppose friends, it has m and n, m less than n case is given, in that case onto function is not at all possible, in that case the answer is 0. So, for the first case this is the answer, second case this is the answer, third case this is the answer. Otherwise, yeah, hi Srini, yeah friends, otherwise you use the formula, that is n power m minus nc1 into n minus 1 power m plus nc2 into n minus 2 power m minus and so on. You know this formula. These are the important points related to onto function, right. Yeah, right. Next, bijection. A function is said to be bijection if it is both 1 1 and onto, that is all. For example, if A, B are finite sets, you can say 1 2 3 4 A, B, C, D. So, you see this function is definitely 1 1 as well as onto, and hence it is a bijective function, right friends. So, when f from A to B is a bijection and A, B are finite sets, you can observe that n of A is equal to n of B. Suppose this is n, the number of different bijections that I can form from A to B is going to be n factorial, right friends. Now, with this synopsis we can enter the problems. You see, if you have idea of the problems, see it is very easy, any problem we can almost close in less than 1 minute, right friends. You see this question, a function f from R to R is given by f of x is x by x square plus 1 for all x belongs to R. We are asked to find whether it is 1 1 or not, onto or not, bijection or not. You see point number 1 friends, to check 1 1 nature, since it is a differentiable function, better you take the derivative. What is f dash x friends? F dash x is, you see it is like u by v, v derivative of u minus u derivative of v by v square. So, friends, this is minus x square by, you can write like x square, of course 1 minus x square by x square plus 1 whole square. Can I say that the derivative is always, yeah, the derivative is, yeah, Ashila, hi, yeah, the derivative is always positive or always negative? No, because you see denominator is always positive, whereas 1 minus x square, in the sense, you see if x square value is between 0 to 1, this is positive, if x square value is more than 1, it is negative. So, derivative is sometimes positive, sometimes negative, in the sense it can never be 1 1, it is not 1 1, and hence it is not a bijection, right, fine. Then on to how to find the range of this. Okay friends, you know linear by quadratic case we find the range is equal to y logic, rather this is a standard function. I think you can find through, you see x minus 1 whole square is always greater than or equal to 0, from this x square plus 1 greater than or equal to 2x, this is a positive quantity, 2 is a positive quantity. I can say that 1 by 2 greater than or equal to x by x square plus 1. So, friends, for any x, x by 1 plus x square is always less than or equal to 1 by 2. That means the output of this function can never be greater than 1 by 2, whereas you just see the codomain. Codomain is given as R. So, range is different, codomain is different, it can never be onto. So, the answer is going to be neither 1 1 nor onto, that is all. You see, for 1 1 function derivative, for onto function observe the range. Only 2 points are enough to answer such questions. Okay, fine. Next, friends, you see this question. Are you ready? Yeah. F of x is this, where step x denotes the greatest integer function, right. So, step x square plus step of x plus 1 minus 3 is f of x. I think if you know the property of step x, like step of x plus n, if n is integer, you can write it as step x square plus step x plus 1 can be brought out, so that this is step x square plus step x minus 2. Without any calculation, I can directly say that this function is not onto. How? You see, friends, for any x, step x square is integer, step x is integer, minus 2 is integer, the output is always integer, some integer, whereas codomain is R. You see, output you may get few or more integers, whereas codomain is R. So, range can never be equal to codomain. So, it is not onto, it is into. Feel like it is a multi-correct answer type, because one of these two options may be correct. So, you decide whether it is 1 1 or not. Now, you just try to say this is not 1 1. Can you give any counter example? You see, that means can you give two x values such that same output comes? Yes. You see, if you take x is 0.1 or 0.2 or 0.3 and so on 0.9, for all these step x is 0, output is same minus 2. So, for all the numbers from closed 0 to open 1, same output. So, this cannot be 1 1, because all these will be mapped to the same number, say minus 2. So, this is not 1 1, so it is many 1. It is a multi-correct answer type question. This function is going to be into and many 1. Clear, dear students? Are here what you need to have is observe the function and try to write in a simple way. Do not think like everywhere we are going to take the derivative for 1 1. Observation is important, understanding the function is important, right. Next, let me take another interesting question. Yeah, this is the function, friends. If you see this, immediately you can say that it is not onto. How? You see here, 4 power x is always positive, 4 power mod x, a power x is always positive. That is the basic point that you will learn in 8th class. So, the output is always positive. So, range can never have negative numbers, whereas codomain is R, it is not at all onto function. So, 1 1 and onto, this option is invalid, many 1 onto, this option is invalid. So, it can be 1 1 and into, many 1 and into, sure that it is into, undoubtedly. Now, what about 1 1 nature? Right, friends, better you try to draw the graph of this. F of x is nothing but, friends, 4 power x plus 4 power mod x. Now, you can split like if x greater than or equal to 0, you see it is going to be, you see 4 power x plus 4 power x, 2 into 4 power x. If x is less than 0, you can say that it is 4 power x plus 4 power minus x, that is the thing. Can you just try to draw the graph of this? When x is 0 friends, this is 2, this is 2. When x is more than 0, as you increase x value, its value increases, as x goes to infinity, it goes to infinity, right. Now, as x is negative, for example, you give minus 1, it is 1 by 4, but this is 4 power 1. So, it is more than 4, minus 2 means it is 4 power 16, as extends to minus infinity also, this may go to almost 0, but this goes to plus infinity, the graph again turns like this. May not be perfect parabola, but it has to go to infinity as extends to minus infinity and infinity as extends to infinity. From the graph you can clearly say that, friends, the function is not going to be 1 1, because if any horizontal line cuts the curve at more than one point, it is not 1 1, right. So, this is many 1 and into option 2 is right answer, 1 is wrong answer. Clear, dear students? Simple and standard questions these are. Once you master these functions, you will automatically get ideas how to handle certain functions, right. Next friends, you see this question, a simple question. A is minus 1 to 1, which is also b. Which of the following functions is going to be a bijective function from a to b? That means, from minus 1 to 1 to minus 1 to 1, it must be a bijection. Fine friends, f of x is x by 2, you know that it is a familiar curve, it is a simple straight line passing through origin at 0 0, at 1 1 by 2, at minus 1 minus 1 by 2, this is minus 1 by 2, this is 1 by 2. Okay. So, clearly it is 1 1, because no horizontal line cuts at more than one point, but this is not onto, because the range covered is only minus 1 by 2 to 1 by 2, whereas codomain is minus 1 to 1, this is 1 1, but not onto. And x square is and mod x is also standard one, minus 1 to 1 mod x will be V shape, you know, it is a familiar one. It is not 1 1, because horizontal line cuts at 2 points. So, this is not 1 1. So, it is not bijection. What about x square? Even x square's graph also you can imagine minus 1 to 1, it will be like this. Okay. So, even this curve, my dear students, this is not 1 1, because it is going to cut the curve at more than one point. So, obviously, this must be the function, because friends, sin pi by 2 x means when you give minus 1 to 1, sine curve at 0 it is 0, when x is 1, sin pi by 2 it goes to 1, sin minus x is minus 1 it goes to minus 1. Even the range is also covered from minus 1 to 1. You see, this is clearly 1 1, no horizontal line cuts at more than one point, and the range is also minus 1 to 1, and hence this is the answer, dear friends. Just if you have idea of some familiar standard simple functions graphs, you are able to decide whether it is 1 1 or not, onto or not. Okay. Chalo, next. What about this function? Cubic expression, how to handle? Fine, it is easier, seems to be little lengthy, but it is easy. First thing, you take the derivative of f of x, which is required even to draw the graph also. You see friends, its derivative is 3x square minus 6x plus 6, you can take 3 common, x square minus 2x plus 2. Friends, I think you know this quadratic expression is an expression whose delta is negative, because you think you can write x minus 1 whole square plus 1. So, whatever x you give, this is positive into 3 positive. So, derivative is always positive, that means the function is going to be strictly increasing. Yes. So, undoubtedly it is 1 1. So, this option and this option are invalid. Now, on to nature. How to find the range of this function? 1 second friends. Cubic expressions graph, if x coefficient is positive, x cube coefficient, leading coefficient is positive, as x tends to infinity it goes to infinity, as x tends to minus infinity it goes to minus infinity. So, friends, I can say that, you see, when x is 0 it is minus 5, it goes like this friends, the function goes like this, yeah, that is it. It is strictly increasing and it goes to minus infinity to infinity is the range. So, range is R, whereas codomain is also R, so it is onto. So, it is 1 1 and onto, my dear friends. Yes, simple. So, you see, a polynomial equation of odd degree definitely will have range R, because you see, if x cube coefficient is leading coefficient positive, ultimately it goes to plus infinity minus infinity. If it is negative, generally we may get like this, fine. Anyhow, a polynomial expression of odd degree will have range R, do remember. If you know that point, without doing all these things, you can say that it is onto function. So, finally, it is 1 1 and onto. Okay. Then next, you see this function f from R to R, f of x is 2x plus sin x, fine. First derivative, you see how derivative is helping us a lot to draw the curve, 2 plus cos x. Cos x has range minus 1 to 1, whatever value you give for cos x, 2 plus cos x is undoubtedly positive. So, the given function is increasing function and hence it is 1 1, surely it is 1 1. What about range? What about range? Is the range is going to be R, how to confirm? You see friends, you just see the graph of this function y is equal to 2x plus sin x is interesting one, at x is equal to it is 0, you see sin x value maximum is 1, so 2x plus 1 and minimum is minus 1. You just try to draw these two graphs. This is a straight line with slope 2 and y intercept 1. This is a straight line with slope 2 and y intercept minus 1. Okay. And definitely our f of x lies between 2x minus 1 less than or equal to 2x plus sin x less than or equal to 2x plus 1. Am I correct? So, our function is going to lie strictly between these two lines, and you can observe that it is 1 1 function. Moreover, as x tends to infinity this goes to infinity, x tends to minus infinity this goes to minus infinity. So, I can say that I am choosing another color, say dark color, right. It is passing through origin, you see it will be a strictly increasing function like this, yeah, this goes between these two lines 2x plus 1 and 2x minus 1. My point is clearly it is 1 1 and range continuous, because 2x is continuous, sin x is continuous, their addition is also continuous, and as x tends to infinity this goes to infinity and x tends to minus infinity this goes to minus infinity. So, the range is going to be friends R. Okay. So, friends, the codomain is also R and hence it is onto. This is going to be 1 1 and onto, and hence it is a bijective function. It is going to be a bijective function, right dear students. In the same way, you see this function f is given like x minus m by x minus n, of course m different from n. Now friends, I think you know the domain of this is r minus n, fine. First of all, what about its 1 1 nature? Take the derivative friends, v f dash x I am trying to find, derivative of u minus u derivative of v by v square, which is going to be friends m minus n by x minus n whole square. You see, if m minus n is positive, it is always positive, negative, it is always negative. So, but it takes a definite sign, either always positive or always negative. So, it is going to be 1 1, undoubtedly it is 1 1 function. What about range? Friends, I think you know the range of this. I already told you ax plus b by cx plus d kind of function, domain is r minus d by c, whereas range is r minus of a by c. This is the range, because you see, you can just take like equal to y, you will get value. So, the range of this function is going to be r minus singleton 1, because you will never get 1 as output, friends. If this is 1, you see what happens, m is equal to n comes, but m is different from n. So, you will get all real numbers as output except 1. So, this is the range. This means in this particular problem, this is the range, but it is given as r. So, range is different, codomain is different. So, this is 1 1 and into option B is the right answer. You see, for contacts you can go through our website infinitylearn.com, as well as you can contact at this number. You will get the information at any point of time. So, dear student, thank you very much. Stay tuned to Infinity Learn. Enjoy the day. Bye bye.